Welcome to
KidMath number 123.
KidMath number 123. A lot of sick people in our house today and last night, right? So we're just kind of taking it easy today. So we're talking about functions and inverse functions. I wanted to go back and talk about something that I actually don't remember if we even mentioned. It's called the horizontal and vertical line test. So we basically have one rule about a function, right? What's our rule about a function?
Well, that for every input, there's exactly one output.
Right. So we have a function f of x is going to take x to y. Okay. Or if we think about it sort of as a set, you got some points in a set here. This function f, takes each point to some new point over here. Okay. But it definitely doesn't do this. Take 1 point to two things. Okay. So that's really important. One output. And geometrically, when we look at the graph of y equals f of x, that one output rule just means for every point x, there's exactly 1 point y. Okay? So this is a function. Okay? Now, it doesn't matter if some things are not in the domain. So suppose I would have said there's a gap in this function here. And for these points in between here and here, there's nothing. That's okay. There's no output for these points, but that's fine. That's still a function. There's just no output. The function doesn't do anything to these points. But the important thing is it's not a function if it does more than one thing to those points. Less than one doesn't matter. Okay. And so in looking at graphs, there's a sort of quick and dirty way to see, which is you do something called the vertical line test. So for every vertical line, you only hit 1 point on the function. And do you see why the so-called vertical line test helps us to tell whether or not something's a function? Can you explain that?
Well, because if you have like a part up here, like just this line segment right here, you hit 2 points.
Okay.
But for every input, there's exactly one output. So this wouldn't be a function. That
wouldn't be a function. So that would mean your little drawing here means when I come down and I hit this value of x, that our function, if this is the graph, our function is sending x to this point and to this point. And that's a problem. Okay. Now for inverse functions, there's a similar concept. Okay. Here I have a graph that's a perfectly nice function. In fact, it looks a lot like what?
Y equals x squared.
Y equals x squared. Okay. The inverse function, what's the geometric way we get an inverse function? Do you remember that?
You reflect it over the y equals x line.
And we reflect it over this line y equals x, and this would produce, can I do a different color? This would produce a graph that looked like this. And what's the problem with this graph?
Problem is you got lots of, like this x value can shoot up here or down to here.
Right. This is a perfectly fine graph. I mean, we can draw this on the board and we don't, explode or anything like that. But it's not a function. It's not a function because there's an x value here that has multiple y values. Okay, and that's a problem. Not a function. Okay, so there's a nice way to tell whether something has an inverse function right off the bat, and that is
the horizontal line test.
Horizontal line test. These two x values go to the same y value. And then when we do look for an inverse function,
the x and y's just flip.
The x and y's flip and they end up right on top of each other. So there's our horizontal line test, tells you whether or not you got your function. Vertical line test tells you whether or not that function has an inverse function. That's pretty neat geometry, actually. Alright? Alright. Good job this morning, huh? Good job.